Today, we're going on an adventure. We're going to follow energy on its epic journey through the living world to unpack a fundamental rule of nature, one that shapes just about everything. We're talking about the 10% rule.
So let me ask you something to get started. You've got lions, right? Apex predators. And you've got bears, also apex predators. So why aren't there any lion-eating bears? Why do food chains seem to hit a ceiling? Well, the answer is all about energy.
To figure this out, we have to start at the very beginning of the story. We need to follow the ultimate currency of nature, not money, but pure energy, to see how it fuels, well, everything.
And believe it or not, that journey begins about 93 million miles away from us. That's right, our sun. It's the ultimate power plant for pretty much every ecosystem on Earth, constantly beaming down light energy. The real question is, how does that light become, life?
This next part is the first and honestly maybe the most incredible step in this entire process. It's the moment that raw sunlight gets turned into an actual meal.
What you're seeing here is basically the recipe for a chemical miracle. Plants are amazing. They take these super simple ingredients, sunlight, carbon dioxide from the air, and water, and through this process called photosynthesis, they create two game-changing outputs, oxygen, which is pretty important, and sugar. And not sugar is key. It's pure, stored chemical energy. Think of it like a tiny solar-powered battery.
And that incredible ability gives plants their official title, producers. They are the absolute foundation of life as we know it. They don't have to go out and hunt for their food because they literally make it themselves, using sunlight. Every single blade of grass, every massive tree, they're all the planet's master chefs.
Okay, so once that solar energy is neatly packed away inside a plant, it's ready for the next leg of its journey. It's ready to get passed on up the food chain.
Now, to keep track of where all this energy is going, scientists use something called trophic levels. I know it sounds a little technical, but it's really just a way of saying what feeding level something is on. Imagine a ladder. Our producers, the plants, are right there on the very first run.
So let's climb that ladder. On the next rung up, you've got your primary consumers. These are the herbivores, the plant eaters, like a rabbit munching on some grass. Then you've got secondary consumers. These are the carnivores that eat the herbivores, like a fox that snags the rabbit. And sometimes you might even get a tertiary consumer, like a big owl that swoops down and gets the fox. Each step up is a brand new trophic level.
All right, so the energy is moving along nicely, from the grass to the rabbit to the fox. But here is where it gets really fascinating, because that transfer of energy, it's not a perfect handoff. In fact, it's really, really inefficient. There's a hidden tax, a cost, to every single meal eaten in the natural world. So, let's go back to our fox and rabbit for a second. That rabbit spent its whole life eating grass, storing up all that energy in its body. So, when the fox eats it, you'd think the fox gets all of that energy, right? 100%? It seems to make sense, but the reality is going to surprise you.
The fox gets about 10%. That is it. Just 10% of the energy that rabbit worked so hard to store actually becomes usable energy for the fox. And this, right here, is the big idea for today. It's called the 10% rule. Every time energy moves up one step on the food chain, a huge 90% of it is lost. Only that tiny 10% actually makes it to the next level.
And this chart just shows how dramatic that drop-off really is. Let's say our field of producers, the grass, has 10,000 units of energy. Well, all the rabbits that eat that grass, they only get about 1,000 of those units. And the foxes that eat the rabbits, they're left with just 100 units. See, the pyramid gets real small, real fast.
So, you have to be asking, where did the other 90% go? Did it just vanish? Not at all. Think about that rabbit. It wasn't just sitting around being an energy bar. It was using that energy to live. Hopping around, breathing, just keeping its body warm, all of that burns energy, a lot of which has lost its heat. Plus, some of it goes into making stuff like fur and bones that the fox can't even digest. So that missing 90%? It was just the cost of doing business, the cost of being alive.
Now this is a super important point. This whole one-way trip for energy, where most of it gets lost, is completely different from how the physical stuff of life, the atoms and molecules, moves through an ecosystem. So here's the key takeaway. Energy flows. It comes into the system as sunlight, gets passed along for a bit, and then exits as heat. It's a one-way street. But matter, the actual atoms of carbon, of nitrogen, of water, it cycles. It gets reused over and over and over again. Those atoms in the rabbit don't just disappear. They become part of the fox. And when the fox dies, they go back into the soil, ready to be used by plants again. Matter cycles, but energy flows.
Okay, let's tie this all together. Let's bring it back to our original head-scratcher. What does this massive energy leak at every step actually mean for how life is structured on this planet?
Well, the consequence is pretty straightforward, but it's profound. After just 3 or 4 steps up the food chain, there's just not enough energy left on the table to support another level. The energy well runs dry really quickly.
And this explains something you've probably noticed about the world. It is covered in green stuff, in plants. There are a lot of herbivores, sure. But top predators, they're few and far between. And it's because it takes a gigantic base of producers to support even one predator at the top, because that 90% tax gets paid at every single step. And there it is. That's our answer. The reason there are no lion-eating bears is that by the time you get that high up the food chain, from the grass to a zebra to a lion and then to a bear, the amount of energy left from that original sunlight is practically zero. An ecosystem just can't support a stable population of a predator that high up. The 10% rules simply won't allow it.
And you know, this rule doesn't just apply to animals in the wild. It applies to us every single day. So if you think about it, if only 10% of the energy from corn makes it into a cow, and then only about 10% of the energy from the cow makes it to us, what does that tell you about the massive amount of energy it takes to produce the food on our plates? It's something to chew on. Thanks for digging into this with us.